is equal to gt. That is, for example, I say x is equal to 3t square plus 4t, correct? And I say y is equal to tq. If you see, x and y are looks independent, but internally they are dependent because they both are dependent on t, correct? So in that case, if you see, I can use this formula. If I want to find dy by dx, I can get first dy by dt and then I get dx by dt. You divide both, you get dy by dx. And the assumption is dx by dt should not be equal to 0 because this comes in denominator and this becomes infinite value. So rate of change of quantity, if you have y is equal to fx, right? If I have to find rate of change of y with respect to x, I'll say dy by dx. So this is nothing but rate of change of y, and this will say with respect to x. So whatever comes in denominator is with respect to, and whatever comes in the numerator is rate of change of that quantity. For example, I say dA by dB. If I say, that means rate of change of A with respect to B. If you make a small change in B, what change it will have in A? dA by dB, rate of change of A with respect to change in B. So we have, for example, I have distance time graph, right? I have x is equal to distance, t is time. So when I say dx by dt, I'm saying rate of change of distance with respect to time, and this is nothing but speed, correct? So dA by dB is nothing but rate of change of A with respect to B. This can be used for any variable A and B where A and B should be linked. If A and B are not linked, this is 0. For example, I'm having x is equal to, let's suppose, 3k square plus 2k, correct? And y is equal to, let's suppose, 2t plus 5t. And k and t are independent actually. If you see, x and y are also independent now. In this case, my dy by dx will be 0 because you make any change in y, any change in x, they are independent of each other. So these things has a value only if both these quantities are related. If A and B are linked, then it will have some values, or else it will be 0. So to understand the concepts better, the question says we have to find